Good afternoon, YouTube. How's everybody doing out there? All right, so it's Greg from GregsTutoringNYC at gmail.com again. Hopefully everybody's doing all right. We're inching closer to the SHSAT. So now we're down to 60-something days. I think about 65 more days. So please pace out your situations. Hello, Leo. Good afternoon again. Yesterday I was kind of under the weather. I still am, and I decided to take a bite-sizable topic that I was kind of half procrastinating on, but eventually we needed to do. This is great for SHSAT grade 9 question, as well as for the Hunter College High School test. It's normally not used in any other middle school kind of exams, including later on, and it's a toss-up whether it really appears on any other standardized tests involving high school admissions. It will be used in later on in high school, certainly in the second grade of high school, and it depends on the class you have. And I can't really recall ever seeing it on the SAT, but it's got to be there in some shape or form. I had an example yesterday. I'll bring it back here, which was this 1AA7 times 5, and we kind of went through 3 scenarios. And we said it became 5, 8, 35. So we kind of went through the gamut of the normal strategies to approach a problem. The first is just divine intervention, where you just look at it and you figure it out. Some examples are easier than others. Most kids, when they look at it, I think, are going to go, "What?" And I know they will, because I've showed it to some kids. But I think once a bunch of percentage of those kids just look at it, they'll figure out that the A is 0 because this kind of captures this here. There's nothing else going on here, and this here matches that. So if you stay out of this for a while, you can kind of figure out that it's a 0. The second approach we took was to basically substitute from 0 to 9, and we did that smart. So we brute force with smart logic to it, and then we solved it algebraically. In this case, the algebraic solution was definitely overboard. There's no question about it. But I did that because I want you guys to get used to how it's done. We know what place values are, but we often throw them away. And if you're presented with a question like this, you should be the kid who gets it right. A lot of kids will get it wrong, and even some kids who know the procedure and so on. It can be tricky to involve that this was 100 and this was 10, so it's 110. Some kid might accidentally put 111, and then there's a little mapping to finally get the algebra we did at the end. So there is a little yin-yang and stuff going back and forth here. So what I'm going to do is give a second example. We're going to do a second example today, which kind of does need to use the algebra. And this one's slightly different. So let me give it here. Let me get a clean side of this paper. So if we have where's my example? 1, 2, 3, 6 times A becomes 9A. So this one, not much can leap out at you on. I'm sure there is somebody who could just stare at this and eventually figure out what the A is. In fact, there is a little bit here you can check, because you have 1, 2, 3 something, and A is not going to be 1, 2, 3, 4, or 5, or even 6, because you have the A times the 1 over here. So you're talking about, when we go from 0 to 9, you're crossing osmosis. So you're really looking at 7 or 8 and 9. It comes at the end of the day. So we could still do the smart brute forcing. So since that's a given here, and again, I'm giving kind of two rigged problems that are easy on both sides of the spectrum of this kind of problem domain and range and stuff like that. So that if you can kind of get the observation part of it, the brute force part of it, and then obviously the actual algebra part of it, you've got all the parts of it, okay? And then it's just a matter of a more complicated example. So this example is more or less what we did yesterday. So let's just beat on it, okay? Give me 1 second. I want to make sure we're live. Yeah, everything is going right. So while I'm doing that again, I'm Greg at GregsTutoringNYC at gmail.com. I do private tutoring. I do one-on-one tutoring. I can meet you in your home, in a coffee shop, in a library. I can also tutor groups. It can also come into schools. There's lots of different approaches here that can be had to help you guys with tutoring. And you can always email me questions, and depending on stuff like that. Okay, so you can email me questions about the process of how to register for things like the SHSAT, because this is a SHSAT specific YouTube, as well as Hunter. There's lots of cryptic and conflicting and complicated registration details and so on. I'm not going to cover them on this YouTube, but you can certainly email me, and I do other YouTubes. If you like this YouTube, I would be really appreciated. But if you subscribe and then look through my channel, you'll see a whole plethora of different approaches I'm taking to this. Sometimes on a YouTube like this, I'm focusing on a specific topic. Some are more general, and some I'm actually letting you do questions and answers. Okay, so I'm across the board on this stuff, both in math and ELA. I have do also the state test and other things like that. I tutor a whole bunch of specialized tests, and if you go through my YouTubes, you'll find out there's a commonality to some of them. I try to struggle and shoot for that as well as trying to shoot you guys for building blocks. So back to this example. So what the heck is going on here again? All right. Well, unlike the example yesterday, this whole thing is a constant. It's a number, 1,236 times A. So yesterday, we kind of used this line to do two parts, and then we just set them equal. So we can do that here too. So the top part is going to be 1,236 times A. And that's it. So in this example, we're done with the top part. So now what we need to do is split the bottom part up. And the bottom part is 9,000, right? Because that's the constant. Plus, and this is the part we don't know, there's the ones column, the tens column, and the hundreds column. So there's 100 A's. And the next one there's 10 A's. And the next one is 1 A. So that's 111 A's. Because if these were constants, that's what we have. The 100, so if this is 5, there'll be 500. We do 5 times its position. 5 times its position would be 500. If this was 3, it'd be 3 times 10 or 30. If this was 6, and that's how we get our numbers like 1, 2, 36 up here. So it's going to work the same way here. So we have 111 A's. All right? And that's our two sides. So let me rewrite it over here. 1,236 equals, and I'm getting rid of the dot because it means there's just that many of them, equals 9,000 plus 111 A's. So this, now we've thrown this out the window. We've redefined the problem into this. And this is just a normal algebra problem now. So we're going to solve for A, just like if we're solving for X. So we're going to take away 111 A's here and take away 111 A's there. All right? So if we do that, we're going to get 5, 2, 1, 1, 1, 2, 5. Okay, on that side. A equals 9,000. We still need to solve for A. So we're going to divide by 1125. And over here, we're going to divide by 1125. So this is the hardest part of the problem then at this point. If you understood all the mapping from here to here, and from here to here, and then solving at this point. So we have a nasty division. So what we're going to do is just test it. Okay, let me make sure my handwriting is good. That's 1125. So if this is 6, it's obviously too low. 8, 8's getting close. 7, so let's try them both. 1125 times 7. In fact, we know it can't be 7 because it ends in a 5, but it might be less. We're trying to shoot for an example where the number's evenly divisible, but it may not be the case. But we know it should be because A is up here. We're dealing with whole numbers. These are digits to numbers. That's what's the unknown digit. Okay, you could argue 1, 2, 3, 6 times 0.5 might equal this here. This problem is dealing with digits. That's why I call it the unknown symbolic digit problem, okay? So we know it can't be this, so we're going to just immediately go and shoot for 8. Because it could be 6 as well. What's the number? 1125 times 8. So we get 8 times 5 is 40, 0, 4, 16, 0, 2, 8, 0, 1, and we get 9. So that turns out to be, seems to be the answer. So the answer would be A, that A equals 8. Okay? So now that we think we have the answer, how about we feed it back in? So I had 1, 2, 3, 6 times A became 9A, A. So let's replace it by 8. So we get 1, 2, 3, 6 times 8, right? So we get 8 times 6 is 48, carry the 4. 24 plus 4 is 8, 2. 8 times this is 16, 17, 18. 8 plus 1 is 9. And voila, we get it. We get it. So again, going through these 3 scenarios, somebody could have stared at this and actually guessed that it was probably 8 straight off the bat, just based on that the original number was a 9 here. And if they didn't get the 8, it was definitely a 7. All right? The other was to use some other choice, and then we confirmed it with the algebra. All right? So this is kind of, once you start doing these, it becomes more straightforward. And it gets more complicated. As I ended the stream yesterday, it could be other things where you could have AB9 plus BA6, could be something like 999 or something like that. I'm just using random numbers here. And on an example like this, you have to figure out both A and B. Okay, and before you go too fast on some of this, sometimes the algebra only brings you so far. And once you get far enough to know that A might be between 7 and 8, and B might be between 6 and 7, then what you can do is go through those four permutations, seeing which actually adds up. But the algebra still helps, because otherwise brute forcing and this smart guessing and so on, it's still possible, but in a lot of examples it can just take too long. All right. So this deals with also a general class of problems about decoding, unscrambling things, just how you approach a problem and break it apart, even beyond the algebra part, all right? It turns out there's some simultaneous equations you can end up to where you have to make educated guesses and so on about that as well. All right, let me see how long we're going here. So what I might do is end this now. Let me see what else I can add to this. What I'll do is I'll bring this topic back up, maybe either in a longer stream or something else. Let me just quickly see if I have a smaller topic we can cover. Maybe that takes 2 minutes. I have 1,000 things stuck in a file here, and let me find one that might be tiny. Nah, everything else is more complicated. Actually, I do see one where I have here with the where the algebra brings us so far, and then you have to make an educated guess at the end. Let me see what I got going on here. Yeah. All right, let me end this now, and it's a bite-sized little piece of tidbits to eat through, and combine it with the other one, the two together. So it should start making sense at this point. So if we did it a third time, even with a more complicated example, it should start making more sense. All right, everybody. Peace out and have a great day.